Welcome to Methamphetamine. Today we're gonna do a hard integral, and this integral is the limit x approaches to infinity, square root of x squared plus 2x plus v minus square root of x squared plus v raised to the x power. And raised to the x power is the hardest part. And how can we get rid of this x? And here, if you put infinity inside, you get infinity minus infinity and then raised to infinity. Wow! Infinity minus infinity is already an indeterminate form. And we have an infinity, this so indeterminate. And to get rid of this power, first we can let our L, this is the limit. Our question is equal to this. And then we're gonna take a L1 on one side, lateral lot. And then because L1, we should put a parenthesis here. Because L1 is a continuous function, you can put it inside the limit. So you can put the power in front. L1 of this x power of x. So you can throw the x in front of this integral. So you can get limit x approaches to infinity and then x times L1 of square root of x squared plus 2x plus v minus square root of x squared plus v. And because this is already indeterminate, so if you put infinity, this is still infinite, still indeterminate form. So how can we do that? We're gonna use our L'Hospital rule. Be sure we should have a denominator should have a function and so as our numerator. So let me write this as this. L1 of square root of x squared plus 2x plus v minus square root of x squared plus v. And that over 1 over x. Let me write it here. If you multiply it by x on both the denominator and the numerator, you can get the original back. Why should we write it like this? So yes, we can do our L'Hospital rule. We can differentiate both the function. So the denominator one is easier, so we can get the derivative of 1 over x, you get negative 1 over x squared. And then this first, you add 1 inside the function, you get 1 over that, right? 1 over square root of x squared plus 2x plus v minus square root of x squared plus v. And you're gonna multiply the inside, the chain rule. Multiply by the derivative of this, you get, and then 2 times square root of x squared plus 2x plus 3. And then we're gonna multiply by the derivative of this once again, you get 2x plus 2. And then minus the derivative of this, you get 2 times square root of something. And then you're gonna do the derivative inside, you get 2x here. So, and what's this limit? And this limit, I'm going to do this limit first. And this limit, the limit at x approaches to infinity, and then this limit, we can just put limit x approaches to infinity of 1, you just get 1, and you can just put a limit inside. So we just need to do a limit of square root of x squared plus 2x plus v minus square root of 2x plus v. Here's the limit. And here, let me put a parenthesis here. And let me multiply by the conjugate. You will see why. Multiply by the conjugate. X squared plus 2x plus v, and then plus square root of x squared plus v. So multiply by the conjugate, both the denominator and numerator, so you can cancel each other out, get the original back. So here, the denominator, you still get the same answers. 3 plus square root of x squared plus v. And then a minus b times a plus b, right? So square this, and then so you can get, and then x squared plus 2x plus 3, you're gonna subtract this, minus x squared, and then minus 3, right? Minus, and then x squared and x squared, they cancel each other out, and so it's 3 and 3. And then here, we can get 2x at the end, right? And here we're gonna divide it by, we want to get rid of this x inside. And here is the no. If you divide it by x here, why do we divide it by x and not x squared? Because if you divide it by x, you can write this as x squared and then take a square root. So you can combine the square root, you get x squared plus 2x plus 3 over x squared. So the first you divide it by x, you get 2, and divided by x squared. Inside you need to divide it by x squared, so you can get square root of 1 plus, we have a 1 here, so we will not get the infinity here, not get a 0 here. And then over x squared, inside you get 2 over x, and then you get 3 over x squared. And then plus the inside you need to divide it by x squared, you get 1 plus, and then 3 divided by x squared. So put it inside, you get 2 over, put the infinity inside, you get square root of 1 plus 2 over x, 2 over infinity, you get 0. And so this is also 0, plus square root of 1 plus this is also 0. So you, over square root of 1 plus square root of 1 is 2. And then 2 over 2 you get 1. So this limit, you can, this is just equal to 1. So we can bring the negative 1 over x squared to here, so you can get limit x approaches to infinity and then negative x squared. And then we're gonna simplify x, 2 cancel each other out. Be sure you have a 1 here, and then 2 they cancel each other out, and then so you can get limit x approaches to infinity and then negative x squared, and then this is just x plus 1 over square root of x squared plus 2x plus 3 minus x over square root of x squared plus 3. And here, let me combine the fraction here. Combine the fraction. Limit x approaches to infinity. And then combine this fraction, we still get this negative x squared, and then multiply, and then x squared plus 2x plus 3 times this, right? And then this time that, x plus 1 times square root of x squared plus 3 minus x times x squared plus 2x plus 3. This is just the denominator, right? And here, we're gonna do the same thing, divided by x at the same time. Divided by x, because if you divide it by x, you can get square root of x squared and then put it inside. You get, the inside you need to divide it by x squared. So let me just do it in our head. But this is annoying. So why don't we do the limit of this? Limit of this is, do a limit of this to get rid of this first. The limit of x approach, this is not negative infinity, it should be positive infinity. Limit x approaches to infinity, and then negative x squared divided by this square root of x squared plus 2x plus 3 multiplied by x squared plus 3. And here, let me multiply inside. If you multiply inside, you get this x squared plus 2x plus 3, and then multiply by x squared plus 3. The inside of the square root, you can combine it. So let me do some algebra here. X squared times x squared become x power 4, and then don't forget about the square root, and then this time that you get 3x squared, this time that you get 2x cubed, this time that you get 6x, this time that you get 3x squared, and then this time that you get 9. So overall you get x power of 4, and then plus 2x cubed, and then it becomes 6x squared plus 6x plus 9. So you can get this right. X squared plus 2x power. And then here we're gonna divide by x squared on both sides, because divided by x squared, you can write this as divided by square root of x power 4. You can put it inside. So the inside you need to divide it by square root of 4, and then here we need to divide it by x squared. So it becomes -1, and then so this is infinity. We don't want an infinity inside, so divided by x power 4 inside, so you can get 1 plus 2 over x plus 6 over x squared plus, and then this 6 over x power 3, and then plus 9 over x power 4. So you can get what? Limit x approach to infinity, and then put all about it. Let me just put -1 here, because after you put it inside, you get 0, 0, 0, 0, and then -1 over 1, you just get -1. So this limit multiplied by -1. So let me just put a negative sign here. So we already figure what's the limit of this. So the last limit we're gonna get is this limit. This is such a hard question. X squared plus v minus x times square root of x squared plus 2x plus v. Let me multiply by the conjugate, but don't put I don't want to put a parentheses here. Let me just use this dot as the multiplication symbol. Multiply by the conjugate once again. And then x plus, you can also write this as this. Multiply, but so many parentheses. I should put another parenthesis here. It will be very, very crazy if you keep putting a lot of parentheses. So I like to use this more. Multiplication, and then multiply by the conjugate, square root of x squared plus v, and then plus, let me just write it here, x squared plus v plus x times x squared plus 2x plus v. So we have a negative sign here. Be careful. So here the denominator, look at the denominator, it keeps the same. X squared plus v plus x times square root of x squared plus 2x plus v. And here, this is the a minus b multiplied by a plus b, so we can guess. Let me do some algebra here. Put a parenthesis here, and then x plus 1 multiplied by x squared plus v, and then square minus x times square root of x squared plus 2x plus v square. So this is really easy. You can put a square here. X plus 1 square is equal to x squared plus 2x plus 1, and then multiply, and then square root and square, they cancel each other out, so you can get x squared plus 3 here, and then minus x squared multiplied by x squared plus 2x plus 3. So we're gonna explain it. So you can get x power 4, and then 3x squared, and then 2x times x squared, you get positive 2x cubed, and then 2x times that, you get 6x, and then plus x squared plus 3, and then minus, let me just multiply the negative inside, so minus x power 4, and then minus 2 times x power 3, and then minus 3x squared. So many things, they are cancelled, they will be cancelled. So x power 4 and negative x power 4, they cancel each other out, and then positive 2x cubed and negative 2x cubed, they cancel each other out, and then positive 3x squared and then negative 3x squared, they cancel each other out. So the last, we will get x squared. Let me write the higher power at first. X squared plus 6x plus 3. And here we're gonna divide by x. Divided by x this time, because we don't want the infinity inside. Divided by x, you will get what's divided by x. So x can write as square root of x squared. So you just need to divide by x squared inside. So let me just do this. Negative infinity, x approaches to infinity. And here, what should we do? if you divide by x here, you divide by x can write as square root of x squared, right? You can, so the inside you just need to divide by x squared. But we can't get rid of x plus 1 here. If you play infinity, you still get an infinity. So why don't we multiply inside? If we multiply inside, it will be so awesome. X squared plus 6x plus 3 divided by square root, and then x plus 1 can write as x plus 1 and then square root of this square, right? Multiply by square root of x squared plus 3. So let me explain it. Multiply inside, you get x squared plus 2x plus 1 multiplied by x squared plus 3. So we already do this. Just square root of, let me just copy it. Square root of x power 4 plus 3x squared plus 2x cubed. And then, let me just do it. Let me just do it here. Don't be lazy. Square root of x power 4 and then 3x squared plus 2x cubed plus 6x plus x squared plus 3. So you will get x power 4 plus 2x cubed plus 4x squared, right? Plus 4x squared plus 6x plus 3. So we get this. X power 4 plus 2x cubed plus 4x squared plus 6x plus 3. Oh, this is so crazy. Another, you just need to multiply x inside, x squared, right? X can write as square root of x squared. So multiply by x squared, you can get x power 4 plus 2x power 3 plus 3x squared. So we can just divide by x squared. So divide by x squared, and then inside you need to divide by x power 4. So negative limit x approaches to infinity, and then divided by x squared, you get 1 plus divided by x squared, 6 over x plus 3 over x squared. So inside you get square root of, divided by x power 4, inside you get 1 plus 2 over x plus 4 over x squared plus 6 over x cubed plus 3 over x power 4 plus square root of, inside you get 1 plus 2 over x plus 3 over x squared. Whoa, this is so crazy. If you put infinity inside, you will get negative 1/2, right? Infinity 0, 0, 0, 0, and then square root of 1 plus square root of 1 is 2. 1/2. In front we have a negative, so negative 1/2. But this not our final answers, because we let L is equal to this, and the Ln of this limit is equal to this. So we can, what is here? Ln L is equal to negative 1/2. So we can raise e on both sides to cancel the Ln. So our L is equal to e power of negative 1/2 is equal to 1 over square root of e. That's our answers. So this is really, really cool. So limit at x approaches to infinity, and then square root of x squared plus 2x plus 3 minus square root of x squared plus 3 power of x. This limit is equal to 1 over square root of e. This is so crazy. Let me give Wolfram Alpha answers to you. Yes, this is the answers. 1 over square root of e, and this is closer to be, let me figure out what's the number. Let me just use our calculator. Wolfram Alpha just 1 over square root of e. This is approach, not approach, don't use approach. This is closer to be 0.6065. let me just write here. This approaches, not oppose, closer, distance is closer to be 0.6065 feet. Let me pick some high number here. Big number, not high number. Square root of parentheses, plus parentheses. Because we need to, no, put a parentheses because we need to raise the power. Then parentheses of square root of, let me pick a number, 100,000. 100,000 square plus 100,000 times 2. 2 times 100,000. Let me just write at this form. Plus 3. Don't just put answers here because it will give you we need to do it as once. This is a calculator. If you do it, don't do that, just don't do that. You will see why after I do it. Let me just do it first. Minus square root of 100,000 square plus 3. And then we're gonna raise to 100,000. So you get this 0.60659. This is just 1 over square root of e, but just this number. This approaches. So you will see why. If you just get this square root of 100,000 square plus 2 times 100,000 plus 3. Yes, you will see. And then subtract square root of 100,000 square plus 3 raised to 100,000 power. Yeah, luckily we get the same answers, but why don't we just do it as once? Just do it as one. It will be faster. So this is the limit of this. Crazy limit. The limit is very, very fun. 1 over square root of e.